Now instead of the flute, we're playing the organ pipe. The difference here being that this end is closed, we still have one open end. So I'm going to go through the same process where I try and figure out the frequencies that this organ pipe can play based on its length. Now, this will look a little bit different. So in order to make sense of this, I've drawn one full wave in my organ pipe. I know that I need to have a node on a closed end and an antinode on the open end. So this red one, let's examine that. That's one full wavelength. So how much of the wavelength is in the tube? Well, this must be half of a wavelength. And if this is at the antinode, so it's half of this, so this portion of the wave must be 1/4 of the total wavelength. So 1/4 of the wavelength is equal to L, the length of the tube. Rearranged for lambda, or wavelength, I get this expression. And I'm doing the same process that I did earlier in relating the velocity to wavelength times frequency, and I'm figuring out the the fundamental frequency of the organ pipe is related to the velocity over 4 times the length of the tube. Now let's look at a few other variations of this. If you were to play at a higher frequency, achieving some standing wave, what's the pattern here? Well, in this next scenario, you've got how much of a wavelength is that? Well, I see half of a wavelength, and then there's this portion here. That's 1/4 of the wavelength. So altogether, the wavelength is 3/4. So the length of the tube encompasses 3/4 of a wavelength, meaning the wavelength is 4L over 3. And I can plug this all into my velocity equation and reach something for frequency, and I get that value there. I do it again for the next harmonic, and I see, well, how many wavelengths is this? I see one full wave and then 1/4. So that must be 5/4 wavelengths as in that tube L. Rearranged for lambda, plugged in, hopefully you're getting the pattern of this in order to achieve a frequency. And now I have to spot the pattern between this and that. I see a 4L on the denominator, and I see a V on the numerator, and it's going up. So I have a 1 here, a 3 here, and a 5 there. So my pattern for frequency in the organ pipe or any closed tube is n times V over 4L, where n can only be an odd number, 1, 3, 5, 7, 9, and so forth. A thing to note here, hopefully this is making sense. If you're looking at a closed open tube system, just remember at a closed end you need a node, and at an open end you need an antinode if standing waves are achieved. Okay, I think that wraps it up. Yes, I'll see you guys soon.